Now it's all about the Bayesian interface, which is the next hypothesis theorem. The procedures we have looked at involved making probability statements about our tests. So there's only 3% chance that you'll observe that the extreme statistic if our null hypothesis were true. So the alternative approach to interface involves treating unknown parameters as the random variables. So let's get started with this interface, naming as Bayesian, so which is called as Bayesian.py. And here we'll start with our logic of developing the interface with the parameters mentioned in Bayesian interface as alpha and beta. First of all, we'll import our math library, that is import math with a value as dfb, comma, alpha and beta. And then comes the next value is return math.gamma with a value as alpha into math.gamma with a value of beta. And the sole value will be divided by math.gamma with the value of alpha plus beta. So what is this interface analysis? It's like when the unknown parameter is there in the probability. Say we are taking two parameters of alpha and beta. Here the Bayes theorem will take a position in such a way like making probability judgment about the test being possible. So you make probability judgment easier as per your analysis. So the unknown parameter is the probability. Now considering for the analysis which is done with the function of df beta underscore pdf. So what it does, it says df beta underscore pdf as x comma alpha and beta. So these values will be treated over here in such a way considering if x less than 0 or x greater than 1, well in that scenario it will return 0. Or else the complete scenario will return a value in the function by default as x raised to, that is into alpha minus 1 into 1 minus x, which will be done in such a way raised to beta minus 1 divided by b into alpha comma beta. So this complete scenario, for that to analyze the output which is to be generated, we'll call for the print parameter as print value as beta pdf with a value of minus 20, 100, 150. And these values will be taken as the analysis for printing up the values. So this section has been done. Now we'll go to our command prompt and print up these values as Python Bayesian theory. So it will be taken as Bayesian theory. So it gives the output as 0. Why it is giving now for 0? Because generally speaking, the distribution center has a weight assigned over here with the parameter, and this will give you a 0 because division is assigning to a value in such a way like if alpha and beta both are 1, considering for the scenario over here. So if alpha and beta both are taken as 1, it just gives the uniform distribution, and if alpha is much larger than beta, most of the weight is near than 1. And if alpha is smaller than beta, well in that scenario over here, it just returns the weight which is near to 0. So that is why we are getting the output over here as 0. So it is no coincidence that the posterior distribution was again a beta distribution. The number of heads is given in the binomial distribution, and the beta is nothing but a conjugate prior to the binomial distribution. This means that whenever you update a beta prior using observations from the corresponding binomial, you will get back to the beta posterior, which has been mentioned over here. So this was the Bayesian theorem. The next is about the best fit theorem, or we can say it is the line of the best fit which is plotted using matplotlib. It includes a test problem where you will get a 3-parameter model which fits in a straight line of the data. So that is also one kind of a hypothesis with the probability theorem. So that we'll have a look in our next chapter.